Howdy, once again, it's tubalcain, your YouTube shop teacher, and I'm a bit discouraged today because in the previous video, number 482, and this is video 483, but in 482 I spent a lot of time attempting to drill relatively large holes with my DC motor and the DC motor control, and it did not have the torque that I expected it to, although I'm still not dissatisfied with the speed control because most of my hole drilling is at small diameter, so it is going to serve me greatly. And that is a permanent installation, and you'll recall that I also put a tachometer on the machine. But to carry this one step further, I'm going to go out in the garage on the Duro drill press. And remember in the last video, number 473, concerning the pull gear, I tested that out. I drilled some large holes, but I had an undersized motor. So let's go out and take a look and see what I'm going to do about that. Now I'm out in the garage at my Duro drill press with the pull gear. There was a whole series of videos on that. I hope you liked them. But here is the problem that I have with this setup. This motor is only 1/3 horsepower. It is greatly underpowered. It is not a capacitor start, and so sometimes just the load of starting a gearbox, that's like starting an old Plymouth with a 6-cylinder in third gear from a stop sign. It doesn't work too good, but sometimes it stalls. Did you see that? It wouldn't start because it didn't have enough torque to even go through the gears and turn the spindle. So I'm going to correct that in a permanent way here, and let me show you how. I forgot to tell you, but in a future video, not too far down the line, I will be using the speed gear in order to slow down a bandsaw for metal cutting. So I'll be using the speed gear, I'll be using a DC motor and a gearbox, another gearbox, to slow down a Delta 14-inch. So you'll see more of this later on. I had in stock here, and I forgot all about that. This is a 1/2 horse motor, 1725 RPM, capacitor start, 5/8 shaft, and I believe it'll be just the ticket for putting on the Duro drill press. I forgot why I had it, but at one time I even had a drum switch, a reversing switch on that, so that's already wired in and will remain on, even though I probably have little or no use for a reverse on this, other than I might do some tapping. But the whole idea is I'm going to mount this, and I'm going to run through some of the same tests with 3/4 drill bits, larger drill bits, into steel, and see if that increases the torque, because there was a fair amount of torque once I got this thing running, even with the old 1/3 horsepower motor. So I will rejoin you in about 1 hour, or whatever it takes me, to install this motor. See you then. Well, that took a lot longer than I thought it would. It was 90 minutes worth of work, and you can see that that's the motor, the old 1/3 split phase, and now we have the Ajax 1/2 horsepower 1725 with the pull gear attached. Of course, the shafts ended up being different diameters. Fortunately, I had made 2 bushings 2 months ago. Remember when I had the wrong size back then, so I did have that in stock and was able to find it, which was a miracle in itself. And as a special bonus, I now have the reversing switch, so that's mounted on there. And I can use that for the on and off, or I can continue to use this switch. There is reverse. Probably never use it. Now look at the way I have the belt set on the step pulley. On the front, I'm the second from the top, if that shows up. Over here, I am in the middle one, and I had talked in other videos about the need to have plenty of wrap of your belt around the pulley. When you're on smaller pulleys, you don't have much wrap, and there's all the more tendency for the belt to slip. Now, I checked the RPM using the Stewart Warner here, and I have 250 RPM. Now, that's going to be a constant here unless I change the pulleys into another step, and I'm not really interested in doing that. But I'm at 250 RPM. Now I'm going to drill a sample here. That's 1/4 inch steel, and it's already got some holes drilled in it, about 3/8 holes. So I'm just going to open them up to 3/4 using a little oil. I'm at 250 RPM. Now if you look up a 3/4 drill bit in the table of cutting speeds, for 100 feet per minute, which is a good speed for steel, it calls for 509 RPM. Now I'm at half of that. Remember that these speeds are all set up for production and efficiency and making money. I'm not making money. I never made any money. I'm just doing this for the pure pleasure, and the slower you run your bits, probably the greater the preservation of the cutting edge. So let's go ahead and drill this and see what happens. See if I stall the motor. That's what I'm concerned about here. 3/4 bit. Now at that point the belt slipped. I'm going to go back and tighten the belt and then do another one, because I had a little interruption of the camera there also. So I'm going to do that one over, and the bit is stuck right now, of course. There she comes. That's just as I broke through. The belt is, a little bit loose. I'm going to make it tighter than a drum. Tighter than it should be, because that's hard on bearings. Quick safety note, make sure that you clamp your work. Don't try to hold it by hand, especially on larger bits, and wear your safety glasses at all times. So I've moved on to the next hole here to see what happens with a tighter belt. That was too good to be true. The belt did not slip, the motor did not stall, and it takes a lot of energy to turn a 3/4 inch bit into steel. This is a 1-inch drill bit. This was 1-inch stock. I can't drill a 1-inch hole in 1-inch stock, so I switched to 1.25" hot rolled steel. I already drilled a 3/8 pilot hole in there, so now I'm going to give this a try at, again, 250 RPM. This is one of those silver and Deming bits. You've seen me use it in the other videos. I do not like these bits. I don't think that they are good. I don't like the way they're sharpened, even out of the package, but that's what I'm going to use. So it's even more of a challenge when you think about it. She stalled, or stuck. Let's try it again. Well, I did it, but it took a little babying, and I don't like the looks of the shavings. Again, as I told you in another video, it looks like they're scraped out. There's no long curly ones. So let me see if I can find a better bit so I could have a better shot at it than this 1-inch bit. I wanted to show you now, before I start the drilling, with this tachometer and the rubber tired wheel on there, I can directly read the cutting speed of a cutting tool in feet per minute. So if you look on the red scale, which is the inner scale there, I'm on about 55 no, a little bit less, 48 or 50 feet per minute. Now that's a 7/8 drill bit, which would call for 100 feet per minute, so I'm really only turning it at about half of the speed, but this is a sharper bit. This is a Hansen high-speed steel bit with a reduced shank. I have a lot more large drill bits in taper shank, but I can't use a taper shank bit on this drill press. It has to be a step shank. So with the 3/8 pilot hole drilled here, I'll go ahead and see how this cuts. And that cut fine. Again, I'm not getting the curlicue chips, but I guess maybe I can't expect that. They look more like they're scraped. So I am very satisfied the way this is operating. Now I think I'll drill some aluminum, although this is way too slow a speed for aluminum. 7/8 drill bit, 1/2 inch thick aluminum, 1/4 inch pilot hole, again cutting at about 50 feet per minute. We could cut up to 300 or 400 feet per minute with aluminum. So it's really way too slow, but let's do it anyway. Absolutely effortless, but it could be done much faster, and it made a nice hole. So I'm trying to show you ways here of drilling large holes at slow speed and on late duty drill presses. These little drill presses like this Duro and the other ones that I have are not designed for really anything over 1/2 inch drill bits. So they don't have the slow enough speed, and in general do not have enough power. They do not have the bearings or the quill or anything else that you need for that for these bigger holes. But I'm kind of forcing this, but that is my want to do in my demonstrations, because this whole thing really is an experiment here, because I've increased the motor size again to 1/2 horse from the 1/3 and its capacitor start. And just everything about this now is better than when I started 3 hours ago. And yes, it took between 3 and 4 hours to make this video, but then again I had to do some mounting there, and I better call it quits here. Remember that in the next video I'm going to show you how to do some slow speed drilling with hole saws. Now I know I promised you that in the previous one, but I'm sneaking another video in here because I wanted to put this pull gear on this machine, on the new motor, but now I'm going to take it off probably and put it on that bandsaw, at least temporarily. Then it'll go back on this machine probably for good. One time you might have heard an electrical sound. This switch is arcing, so I'm going to take that switch out and replace it with a heavier one, or just bypass that totally and use the drum switch, and I gotta tighten that up, the drum switch to do the on and off, because these little switches here aren't really rated for larger motors, and plus this is very old, so it just seems to be arced. This one's okay for the light. Alright, that concludes again a video that ran way too long. Hope you enjoyed it. Watch my many other videos. This is tubalcain saying so long for now, and I just had 4 cups of coffee.